Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. I am Vangelis Prokopiou and today you will be watching Rust logging, simple and complicated setups. I will describe and showcase this topic in this video, logging, because it may seem like an easy issue, an easy task, but depending on your setup or on the application setup, it may be quite complicated. So I will go through some setups, and what we will cover are at least 5 things which I will enumerate now. We will set up a logging for an application which has a simple name. You will see what I mean during the video. We will see how we can handle the logging of third-party libraries that we may use in our application. We will see how we can handle logging with applications that contain dashes in their names because they need special handling. We will see logging when we have an application where the binary is renamed. You will also see what I mean later in the video. And the last point that I will address is how you can set up your environmental variable handling in a command line application. These are the topics that I will cover. So let's get into the video, but before starting I would like to introduce another co-host to you, and this co-host is, just a minute, is my very sweet guinea pig. Here he is. He will be joining us for the video, and he's very cute, I believe. So let's continue with the video. Okay, let's escape here and let's come here. I have already an application set up which is named foo, as you can see, and let's inspect what this application contains. As you can see, I also include the hyper and the Tokyo crates, and what we do here is we execute a request here. We're using the client, we're executing a request here. We do some stuff which we don't care about, I just have them in here, and then later we also have a server, and the server is listening for requests from us at localhost, as you can see here. So let's start by building this application. Let's come here and let's say cargo run. Okay, we have the application runs, and if we check this, it is working. It gives us hello world, which comes from this handler, which is the hello handler, and it just returns hello world. Okay, so far so good. Let me stop the application, and now what we want is start adding logging to our application. So the first things that we will do is that we will add some crates, and these crates are the env logger and the log crates. Cargo add cargo and vlogger. What am I doing wrong? Cargo. Oh, I started by forgetting what the command is, so let's go and do it here from the docs. We will say rust env logger see the examples. Yeah, No, I don't want this, sorry. Crates, let's go to crates.io. Rust crates.io, and we search for env logger. Okay, we get this, both of these. We will come here at our cargo toml. We will add this, and let's go run the application to make sure it runs again. It builds and it runs. Okay, the application builds and runs, so we're good to go. We have successfully added these two crates and we are ready to start logging. So let's come here and let's come here at our main and let's env logger init. This is how we init the logger, and then we will say log error, and we will say here main error, and then we will say here warn. Here we will say info, and let's use as the last one the debug level, and there's also the trace level, but we will not use that. We will come up until the debug level. So this is how we start. We initialize the environmental logger, and then we add our log statements. So let's run this application and see what will it do. You see that we indeed got logging here, and we have only the error message here. So only this line executed. Only this statement, the logger error. So we extract some useful information from here, and that useful information is that, as we can see, we by default during logging we start with the error log level. So everything that it is an error will be logged. This is our first piece of information that we can gather. Now, the logging, if we go to env logger, let's go this time here to the, not here, to the docs. Let's go to the docs. So we will say, no, we won't say something. We will come here and we will say env logger docs. Yes, here. Let's come here. So we have some information here, and as you can see, we start. This is the environmental variable that controls the logging, this one, the Rust log, and by default we start with the error level. So let's start tweaking this variable, and let's come here and let's say that we want this to be equal to warn, and then we will cargo run our application. And as you can see, indeed, we updated this variable and we got the warn message too. So let's try the next level. Let's go info, and you will see that we got everything up to info. So far so good. Let's try debug. We have debug, nice. As you can see, everything executes. And now let's try, let's add the trace too. So we will add J, and we will say trace. And let's see what will happen now. So we will say that this equals to trace, and we will start executing. Now we come to something very useful. Here are all our log information, our own logging, as you can see, all these executed, and we can see them here. But we also get something else. And what is that thing that we get? We get logging from the Mio library, as you can see. These statements are not coming from our own code. We have nowhere any other log statements, but we are getting more logs from a third-party library that we included. Mio is included through Tokyo. So we're coming to our second point that I want to discuss, and this is how we can enable logging only for our own code. So in this situation, as you can understand, we don't want this logging from Mio, but we want the logging from our own code. So if we come here to the documentation, to env-logger, and we search, here it is. As you can see here, it says that there is also a sudo logging level off, which may be specified to disable all logging for a given module or for the entire application. So as we can see, there is this off level. So we can try this. Let's come here and say that we want to set this to off. And let's rerun. As you can see now, we got no logging either from our application or the Mio library. But this is of course not what we want. We want to disable logging for the third-party libraries and enable logging for our code. So this is not good enough. So if we search more the env-logger documentation, we can see that this rustlang accepts a comma-separated list of various values. As you can see here, we have hello for our hello module, also standard option, we have error and hello off, etc., etc. And this first value at the first comma is the global setting. So what we could effectively do is that we could say here off, as it already was, for disabling the global logging for everything, and then we could add a comma and then add logging for our own application. So in this case, we can say that our application, which is called foo, if you come to here to the cargo terminal, you will see that it's called foo, and we can say that here we want, let's say, trace, and let's run the application and see if we get only our trace log statements. And indeed, as you can see, we get all our statements, but we get nothing from the Mio library. So this command indeed fixes our problem. Of course, this is not the best, let's say, setup. The best setup would be to set the global error, the global logging to error, so that we have errors not only from our code, but also from underlying third-party libraries, and then set our own level for our application. So if we run this, again you will see that we get currently only the log information from our own code, and we get nothing from the third-party library because we don't have any errors currently. So that is nice, I think. Okay, good. So far so good. Now, let's come to our third point, which is what happens if we have an application that includes dashes. So let's come here, let's comment this code. Let's come here and let's say that we want to call this foo app, let's say. So we change the name and let's rerun the application. Currently we don't care about this because we do not include any debug statements, so let's run just to make sure that it builds. Excellent, it built and it ran. And now let's go to add our logs again. And let's come here and say that our foo app will be the logging level for our own application, for the foo app, will be trace. And let's set, let's set, let's set it to off so that we don't get any logging from any other third-party library. Okay, let's run this and see what will happen. It seems that we did not get anything from our application. Now, why does this happen? If we check the docs here, let's check for dashes, no, underscores here. If the binary name contains hyphens, you will need to replace them with underscores. So this is something that we have to take into consideration. This is the example. So what we have to do here, not here, sorry, here. What we have to say is foo underscore app instead of foo minus app. So let's run this. And indeed, again, we have our logging. And also, as you can see, the logging provides us with the name of the module or the application that we're running. Okay, that's nice. So we covered also the names with dashes. Let's proceed now. No, let's not proceed. Let's come here and also now we will see what happens when we have other modules. So we will add librs. We will come here and we will say that we want a new Rust file and we say lib.rs. And here we will add the function which we will call hello, for example. And what will this do is that it will print line hello from lib, let's say. And let's include it into our main file here, and let's say that we want how did we call our application? Foo app. Foo app hello. And let's run the application. Foo app trace. Okay, let's go. Okay, we have the logging from the main file. You see main here. The application runs. So let's go here to hello and let's add the same logging. And we will say here lib.rs. So let's come here and rerun. And as you can see, indeed, we have all the logging from the main file, main.rs, and we also get the logging from our lib.rs. So our logging works excellent with this kind of setup. Off for the global logging and foo up equals trace. Now, let's go now to the next point, next issue that I want to cover, and this is how we handle logging when we have renamed binaries. So what do I mean with renamed binaries? Here, if we come and we define this and we say bin, we can say that the name will be equal to ham, let's say ham, and the path will be equal to src main.rs. Okay, let's go and build the application and see what happens. Now, as you can see, we have the logging only from the library. As you can see, lib.rs here, etc., etc. So everything that is logged comes from this lib.rs file, and nothing comes from the main.rs, which means that, of course, the name of the binary of the executable has changed. It is not still foo up, it's not foo up, but obviously it must be ham. So let's try this setup. Indeed, as you can see, we got our logging from the main.rs, from the main file. We got back our logging, but at the same time you see that we lost the logging from the lib.rs. So this means that still the configuration is not 100% correct. Now if we go again to the documentation here, I think, no, let's go a little down. As you can see, we can use these directives, path to module, etc. And if we come here, where is it? Control find off. Here. Let's see here some examples. We see that we only have two values here, but if you dig into the documentation, you will see that you can declare multiple modules in the setup. So if we come to our terminal, here the ham is now the main application, and the lib.rs has a different name, and the name of the lib.rs is what we have defined here in the cargo toml. So the lib.rs is called foo up. So let's come here, and again we have to change the dash to an underscore, and we will say that for the librs we also we want a level of trace. So the logging is off for the third-party libraries, and it is trace for our renamed binary. If you remember, sorry, here we renamed the binary to ham, and we're saying that we want the ham main application to have a level of trace, but also we want our module, which is foo app, and it corresponds to this name and to the librs package, to also have a logging of trace. So let's run this and see what happens. Indeed, as you can see, we have our logs from the main rs, the ham, the main application, and our library. So we got all the logging back. Excellent. So this is the correct value that we have to provide in our instance. Of course, we can play with these values. Let's say that we want, for example, only an error level for our library, for the foo app, and here let's say that we want info. So let's see what this will create. As you can see correctly, we get all the logging up to the info level from the main application here, and from our lib, from the library, we only get the error log here. So our logging works flawlessly. This is very nice. Now, we covered all the points that I wanted to cover, and now the last thing that I want to cover is how to handle this these logging levels in a command line application. So let's say that this is a command line application, and we have to add logging and enable logging and handle this various logging level. How would we go about implementing that? Of course, one way is to provide these values somehow from the environment, somehow, either from a .env file or whatever else, or we can do what I will show you, which in my opinion is more intuitive. So let's dig into what is the solution. And the solution is, first of all, we have to create a clap application. Clap is a command line parsing library for Rust. So let's cargo add clap. We'll add work now. I know why add is not working. It just hit me. I was recently trying to build an application, a library, sorry, and I had an error, and what I finally did was uninstalling Cargo and Rust and reinstalling it. And this uninstall seems that removed this add command. I have to re-add it. So since I don't have this, we will add it manually. So let's go to crates.io again. Crates, and we will search for clap. Here is clap. Do we have here any examples? No. Okay, let's get this. Let's come to our Cargill toml. Let's add clap. And now let's go to the clap documentation here. And let's let matches, let's get this one. Copy. Main rs. Let's include this. To make it input arg with name v. This is what we want, the verbosity. We will keep this. We will get rid of this. We will get rid of this. And we will get rid of the subcommand too. Okay, author does awesome things. This is v, sort v, multiple true, help sets the level of verbosity. Excellent. Let's go now and let's run the application. Cargo run H in order to build clap. Excellent, we have a successful clap application, as you can see here, and we have this flag which sets the level of verbosity. So what we can do is use this flag in order to to set the verbosity level during runtime. So let's go and implement that. Here matches, and we will say that match, let's say matches dot occurrences of v. So we are matching on this argument, on this flag, on the v flag, and what we are matching is how many times we have this. So we will come here and we will say that if we have it 0 or 1 times, we want to, for now, print line 0 or 1. For now, this is what we will do in order to see if it works. So we will come here and we will say that we want to reset and we want to run, let's say 2 times the v argument. V. Let's see what happens. Hello from lib. I don't see any logging. Why is that? Arg with name sort v, multiple get matches occurrence of v, print line 0 or 1. Okay, we added 2. That was my bad, sorry. So we will add it with only 1. And we see indeed that it works. We had 1 and we got the logging. So what we have to do here is set the Rust log environmental variable according to this setup. So what we have to do here is use the std env set var. Our var is rust log, and the value is, let's define the values and say that the default will be error, so 0 or 1 will be error, and the value that we want to provide is let's say like it was in the terminal, if you remember. Let's go a few commands back, and this is our current setup. So the value that we want is this. Copy. Let's come here and we will say this is our setup. So if we have 0 or 1 occurrences of the flag, we will set the value to error for our executable and error for our library and off for the global logging. So let's continue here and say that if we have it 2 times, we will set it to warn. If we have it 3 times, we will set it for info. And if we have it 4 times, we will head it for debug. And if we have it more times than 4, we will set it to trace. So as you can see, we can manipulate the debug log level during runtime with this flag. So let's start testing this. As you can see, first we set our rust log variable and then we init the logger. So I think we are ready to start testing this. Let's go here and say the command is this. Let's run with no flags set and see what will happen. As you can see, we have error log reporting both from our executable and from our library, which is correct because here we set for the 0 times. So if we don't have this flag, we are still setting our log level to error, and this is correct because we want to have error logging in all possible situations. So let's rerun with two instances of the flag, and what we are expecting is warn level. So let's see if it will work. And as you can see, indeed we have all the messages for both the application and the library up until to warn level. So let's retry for the info level. Indeed, again, works correctly. Let's go for the debug level. Excellent, we have debug level. And the last one is the trace. And we will add multiple of these. It doesn't matter. Excellent, and we have trace level logging both for our executable and the library. Let's go to the code. Here is the code. And I think this is all the information that I wanted to share with you in this video. I hope that it will be useful, because as you saw with the various setups, logging is not always very straightforward, but hopefully this information will help you in the future setting up your own logging for your own application. So as I said, that's all that I wanted to share. Thank you for watching and have a great day.